Hello, my dear students. Let us discuss with the next type of dam, that is steel dams. Steel dam is a type of dam that is made of steel rather than common masonry, earthworks, concrete, or construction material. Steel dams are constructed with a framework of steel with a thin skin plate as deck slab on the upstream side. In India, no such dams has been constructed. Maintenance cost is high due to rust and corrosion. And usually the steel dams are of two types, direct strutted type and cantilever type. In the direct strutted type, the load on the deck plate is carried directly to the foundation through inclined struts. In the cantilever type, the section of the bent supporting the upper part of the deck is formed into a cantilever truss. This arrangement introduces a tensile force in the deck girders, which is resisted either by anchoring the deck girder into the foundation at the upstream toe or by framing the entire bent rigidly together so that the moment of the weight of the water on the lower part of the deck may be utilized to offset the moment of the cantilever. Let us discuss some of the advantages of steel dams. With the modern methods of steel fabrication, greater speed can be achieved in construction, and also they have been found to be cheaper than other rigid dams. Next advantage is stresses in steel dams are more determinate. Hence, section can be designed economically and with confidence. They have greater flexibility to resist unequal settlement without excessive leakage, and also they are not affected by frost action. Leaky joints, if any, can be repaired more easily by modern welding processes than in hollow concrete dams. These are some of the advantages. Let us discuss some of the disadvantages. The first one is steel dams are lighter, hence are not as adaptable to absorb the shock from vibrations of spilling water. And also the life of steel dam is known to be shorter than a concrete dam. Steel dam requires greater and more constant maintenance than concrete. They have to be anchored at foundation, which is difficult and precarious. And also there is considerable concentration of bearing stresses. So this is about steel dams. Next, let us discuss about the timber dams. Timber dams were widely used in early part of industrial revolution and rarely used now. A timber dam is constructed of framework of timber struts and beams with the timber plank facing to resist water pressure. A timber dam is an ideal temporary dam. Through a well-designed, constructed and maintained timber dam may last 30 to 40 years. They are suitable to places where timber can be available in plenty. Timber dams are normally found to be of three types. The first one is a frame type, second one is a rock-filled crib type, and third one is beaver type. So let us discuss some of the advantages of timber dams. It is of low initial cost, suitable for any type of foundations. Where only temporary dams are to be constructed, timber dams are more suitable. Greater speed in construction can be achieved. And disadvantages are high maintenance cost, life is short, suitable only for small heights, and greater seepage loss through the body of the dam. These are some of the disadvantages of timber dams. Let us discuss the next type, that is earth-fill dams or earthen dams. The dams, which are constructed of earthen materials such as gravel, sand, silt, and clay, are called as earthen dam. And earthen dams can be constructed from materials found on site or nearby area. Earthen dams are relatively smaller in height and broad at the base. Earthen dams are constructed where the foundation or the underlying materials or rocks are weak to support the masonry dam, or where the suitable strong rocks are at greater depth. They are mainly built with clay, sand, and gravel, hence, they are also known as Earthfill Dam or Rockfill Embankment Dam. They are cost effective and also usually they are trapezoidal in shape. So, next let us discuss about the Rockfill dams. Rockfill Dam is an embankment which uses variable sizes of rocks to provide stability and an impervious membrane to provide water tightness. In this type of dams, there is an impervious core of compacted earth fill or a slender concrete or bituminous membrane, but the bulk of the dam volume is made of coarse-grained gravels, crushed rocks, or boulders. The stability of the outer shell of a rock-filled dam relies on the frictional forces acting in between each rock gravel piece, which ensures its safety against sliding or failure during earthquakes. These are embankments of compact granular soil in combination with impervious areas. These dams are resistant to damage from earthquakes. In modern practice, the Rockfill Dam has four fundamental parts, that is, dumped rockfill at the downstream, upstream rubble cushion of laid up stone bounding into the dumped rock, and upstream impervious facing resting on rubble cushion, and upstream cutoff to check under seepage. Let us see some of the advantages and disadvantages of earth and rockfill dams. Earth dams can be constructed almost on any type of available foundations. However, rockfill dams impose some restrictions on the quality of foundation, but they are much less rigid than those required for any other type. And the second advantage is that they can be constructed rapidly with relatively unskilled labor and with materials available on the spot. Hence, it can be constructed even under famine relief work. They are generally cheaper than other types and they can be subsequently raised in height without much difficulty if such a need arises in future. Let us discuss some of the disadvantages of earth and rockfill dams. They are more vulnerable to damage by floods and fail suddenly without sufficient warning. They cannot be used as overflow dams. Separate spillways are to be provided at some site away from the dam to pass the surplus discharge. They are not suitable at the locations where heavy downpour is more common. They require heavy maintenance cost and constant supervision. So this is about Rockfill Dam. Now let us see what is composite dam. Composite dams are combinations of one or more dam types. Most often a large section of dam will be either an embankment or gravity dam, with the section responsible for power generation being a buttress or arch. So, this is about the different types of the dams. Now, next part, let us discuss about the selection of the type of the dam. The selection of the type of the dam at a given site depends upon many physical factors. such as topography, geological and foundation conditions, available materials, suitable site for spillway, data about earthquakes, etc. It is only in exceptional circumstances that an experienced designer can say that only one type of dam is suitable or most economical. Preliminary designs and estimates are required for several types of dams before one can be shown to be the most economical. Before selecting the best type of dam at a particular site, one must consider the characteristics of each type of dam as related to the physical features of the site and the adaptation to the purpose the dam is supposed to serve, as well as economy, safety, and other limitations. The choice of a dam may also be guided by many local problems such as availability of labor and equipment, accessibility to site, uh, limitations imposed by outlet works, and cost of protection needed from spillway discharge, as well as time required for its construction. So let us discuss some of the important one. The first one is topography. The first choice of dam is usually governed by the topography for the site. A low rolling plains country suggests an earth dam with a separate spillway. A low, narrow, V-shaped valley suggests an arch dam, provided the top width of valley is less than 1/4 of its height and separate site for spillway is available. A narrow stream flowing between high rocky walls would suggest a concrete overflow dam. For intermediate conditions, other factors such as foundation condition, location of suitable site for spillway, and availability of materials of construction play an important role in the selection of the type of dam. The second one is geology and foundation conditions. This is the next important factor. If the foundation consists of sound rock with no fault or fissures, any type of dam can be constructed on it. Rocks like granite, gneiss, and schist make very satisfactory foundation for gravity dam. However, these rocks may have seams or fractures. The removal of disintegrated rock together with the sealing of seams and fractures by grouting will frequently be necessary. Poor rock or gravel foundations are suitable for earth dam, rockfill dam, or low concrete gravity dam. Since there will be considerable under seepage in this case, effective water cutoffs or seals have to be provided. Silt or fine sand foundations have the problems of settlement, seepage, and toe erosion. Hence, such foundations are suitable only for either earth dam or low concrete gravity dam, but not rockfill dams. Clay foundations have often the problems of long range consolidation under the weight of the dam, resulting in cracks. Hence, only earth dams are suitable with proper foundation treatment. Gravity dams or rockfill dams are not suitable on clay foundations. Next factor is the materials of construction. The next this is one of the important factor, the availability of materials of construction for dam. The cost of construction of a particular type of dam will depend upon the availability of the materials in nearby area so that transportation charges are reduced. If sand, gravel and crushed stone is available, a concrete gravity dam may be more suitable. If, however, coarse and fine grind salts are available, an earth dam may be suitable. The preliminary selection of a particular dam based on the first two physical factors must correspond with the easy availability of the materials required for its construction. Otherwise, the type of the dam should be dropped. So, Next one is spillway size and location. This we will discuss in the next lecture. I hope all of you understood. Thank you.